You know how your doctor's office and the local hospital just can't seem to share your medical records easily? Well, you've stumbled upon one of the biggest headaches in healthcare. The solution lies in two little acronyms you are definitely going to see on your exam: HL7 and FHIR. So, in this explainer, we're going to demystify them so you can walk into that test feeling ready. Okay, here's how we're going to break this down. First, we'll get right to the heart of the problem that makes sharing health data so darn difficult. Then, we'll look at the first big attempt to fix it, HL7, and see the groundwork it laid. After that, we'll jump to the modern solution, FHIR. And then, at the very end, I'll give you a cheat sheet of what you absolutely need to know to ace this on your exam.
So let's kick things off with the big why behind all this. Data interoperability. I know, it sounds super technical, but it really boils down to a pretty simple question.
Seriously? In a world where you can order a pizza from your phone in seconds, why can't your doctor and hospitals seamlessly share your data? It seems like it should be easy, right? But this is the core data silo problem. Just imagine each system, the clinic, the hospital, the lab, all speaking a completely different language. That's exactly why standards like HL7 and FHIR were created, to be the universal translators and tear down those walls. So the very first step is what we call technical interoperability. And honestly, the best way to think about it is like a digital courier service. Its only job is to get a package of data from point A to point B. It doesn't peek inside the package. It doesn't care if it's a critical lab result or a pizza order. It just delivers the bits and bytes. But here's the thing. Just delivering the package isn't enough, is it? The system on the other end needs to be able to open it up and understand what's inside. And that brings us to the first major attempt to solve this meaning problem, an organization called Health Level 7, or, as we all know it, HL7. So, what's the deal with HL7? For your exam, you gotta remember this. It's a nonprofit organization that decided to create a common language, a lingua franca, for healthcare. The big idea was that a system from Company A could send a patient admission notice, and a totally different system from Company B could understand it right out of the box. It was a massive step forward. And this diagram here shows you exactly how it works. System A doesn't just shout its own private language across the network. No. First, it translates its data into the standard HL7 wire format. That's our common language. That standard message travels across, and then System B translates it back into its own internal format. This two-step translation, that's the secret sauce.
So how on earth do you create one language that can describe everything from a simple billing code to a really complex surgical note? You can't just start writing code. You gotta go deeper. You need a universal model for all healthcare information. Now, this next part gets a little, well, abstract, but stick with me because it is the foundation for everything that comes next. This is the HL7 Reference Information Model, or RIM. Think of it as, like, the constitution for all healthcare data. It's this highly abstract, conceptual framework that tries to describe any possible event in healthcare using just a few universal building blocks. It's incredibly powerful because it's so comprehensive, but you can't just directly implement it. It's pure theory. Now, this slide is super important, a classic exam topic, RIM versus RMIM. If the RIM is the universal theory of architecture, and RMIM, that's a refined message information model, is the specific blueprint for building one particular house. It takes those abstract concepts from the RIM and makes them totally concrete for a specific use case, like ordering a lab test. So what does this abstract theory level even look like? Well, it's pretty wild. Instead of just saying patient or doctor, the RIM uses these super generic, almost academic terms. A person is an entity. That entity can play a role, like patient, and that role can participate in an act, like a hospital visit. It's a very top-down academic way of defining the world, but it's designed to cover every single possibility. But then, boom, we move from that abstract theory to the concrete blueprint, the RMIM. Here, that generic act becomes a specific encounter. The roles become a real patient, John Doe, and a real doctor, Dr. Smith. And we can attach real data, like an observation. This is the level developers can actually use to build something. Okay, so that RIM/RMIM approach, academically it was brilliant. But in the real world, man, it was incredibly complex, super expensive to implement, and all the while, the rest of the world was building simple, fast apps on the web. Healthcare really needed to catch up.
And the answer to that need was FHIR. And this quote right here, it says it all. This is the entire philosophy behind FHIR. Instead of inventing another set of complicated, healthcare-only rules, the creators just looked at what made the web work so well. Simplicity, standardized communication, small reusable pieces, and they decided to bring that exact model to healthcare. And the magic behind the web is something called a RESTful API. I know it sounds fancy, but you use it 100 times a day. When your weather app needs the forecast, it sends a request to a weather server, and the server sends back a response with the data. It's a simple two-way conversation. FHIR just applies that same simple ask and receive model to patient data. Now, for your exam, if there is one single thing you remember about FHIR, it's this word, resource. Everything in FHIR is a resource. A patient, that's a resource. A lab result, a resource. An appointment, you guessed it, a resource. Think of them like standardized, predictable Lego bricks of health information. They're simple, they're self-contained, and you can link them together to build anything you need. So what does one of these resources actually look like under the hood? Let's take apart one of the most fundamental ones out there, the patient resource. Okay, but before we even look at the patient data, check this out. This is a small but really powerful tool called a value set, and its job is basically to be a bouncer at a club. For the gender field, it says, note, you are only allowed to use one of these 4 specific codes. And this is critical because it stops one system from using M while another uses male, which keeps the data consistent and reliable everywhere. And here we go, the actual blueprint for the patient resource. Just look at this compared to that abstract entity and role stuff we saw earlier, right? This is simple, it's logical. There's a section for IDs like a medical record number, and a section for basic stuff like name and birth date. It's clean, predictable, and easy for anyone to understand. That is the FHIR difference. And this is what it looks like in the wild. It's in a format called JSON. And the best part is you and I can just read it. It's not some crazy code. You can clearly see the fields we just talked about in the blueprint, like name and gender, filled in with data. This simplicity is exactly why developers find FHIR so much easier and faster to work with. So look, this isn't just some theory. FHIR is being used right now, all over the planet. Let's look at a couple of big examples, and then we will wrap this all up with your exam battle plan. And we are talking massive scale here. India, they're building their entire national digital health system using FHIR as the backbone. The UK is using it to give patients direct access to their own health records. And hey, when tech giants like Google build their healthcare platforms on FHIR, you know it's a standard that is robust, scalable, and for sure here to stay. All right, let's lock this in. Quick fire recap, you ready? 1. Interoperability, that's the goal. 2. HL7, that's the organization. 3. RIM, the abstract theory. 4. RMIM, the specific blueprint. And 5. FHIR, the modern web-based standard that uses resources. Got it? Good. Finally, here's your game plan for the exam. Number 1, always start with the why, the data silo problem. Number 2, be ready to contrast the old and the new, the academic complexity of RIM versus the web-based simplicity of FHR. Number 3, when you see FHR, your first thought should be the word resource. And number 4, use that web analogy. Explain that FHR works just like the rest of the internet. Nail those 4 points and you're set. And as you're studying, leave yourself with this question. With data this fluid, what does the future of truly personalized medicine actually look like?